Hey, welcome back, guys. And we're starting section 3 under part 4. This covers the topic of lists. We kind of briefly talked about this in past videos, but lists are basically arrays in Python. If you're familiar with other programming languages like JavaScript, TypeScript, um, Java, C++, they're most commonly referred to as arrays, but in Python, formally, they're called lists. They behave very, very similarly. They have uh, a lot of the same similar intrinsic functions and methods that come along with it. In fact, I'll demonstrate here. Let me just zoom in. So if I type Python here on my workspace and I do type in dir for directory plus and then open parentheses, square brackets, closing parentheses, and I hit enter, and these are all the functions or methods that come attached to lists or list data types in Python. So as you can see, there's a whole bunch of them, but some of them that I think we're going to cover in this reading, in this section, will be append, index, insert, reverse, sort, remove. And there's a couple more, kind of hard to see when I zoomed in. Let me zoom out a little bit. But yeah, there's clear, there's append, there's sort, reverse, remove, pop, insert, count, copy. So these are, similar to when I showed this last time, right? These are all the methods that come with working with strings. So if you have a string data type in Python, you have a split function. We used this in one of the exercises in the previous video. You have a right split, a left split. You can convert a string into lowercase. You can check if a string is uppercase, etc., etc. So there's so many functions in Python. With certain data types, but the ones that I listed before the demonstrating these string methods, the string functions, like append, remove, insert, those are in relation to list data types. So I already have TMC loaded up on my VS Code. I have the exercises for this section already opened up. I went through the reading just a little bit just to see how many exercises there are. And I think it should just be these 7 in the entire reading. As I mentioned in previous videos, every video will cover an entire section moving forward, so we don't have to keep cutting the videos in each section into like 10 different videos just to get through the material. All right, so yeah, TMC is loaded up on VS Code. I went through the previous video and I noticed that it might be a little bit harder to read if you're watching these videos on mobile or on a small screen. So I'm just gonna zoom in a little bit and keep the VS Code window zoomed in, and I'm gonna do the same thing on the course website here. So just the material could be a little bit bigger and a little bit easier to read. I'm gonna keep this sidebar here closed for the most part. If you just click on the Explorer here on VS Code, it's gonna open and close it. You can also do Control Shift and E on your keyboard, and it does the same thing. Oh, excuse me, Control B, and it does the same thing. But Control Shift E will open it, or Control B to close it, and then Control B will also open it. So they do the exact same thing. So that's what we're gonna do, just to keep everything kind of more legible and easier to see the code that's being written on the screen. All right, so the learning objectives. After this section, you will know what lists are in Python. You'll be able to access a specified item within a list. You will know how to add items to a list and how to remove them. And you will be familiar with built-in list functions and methods. Thus far in our programs, we have stored data with variables, each bit of data usually having its own named variable. This obviously has some limitations, as it can get cumbersome to define separate variables for everything when there is a lot of data to handle. A Python list is a collection of values which is accessed via a single variable name. The contents of the list are written within square brackets. The value contained in the list are called items or sometimes elements. The following command creates a new empty list. So we have a variable here called my underscore list, which is equal to an empty list, which has an opening and closing square brackets. Whereas this command creates a list with 5 items in it. So again, we have a variable here called my underscore list. It's initialized with a list, opening parentheses, opening square brackets, followed by a bunch of integers here, 7, 2, 2, 5, 2, and then followed by a closing square bracket. So this is the anatomy of a list or a simple list in Python. All right, accessing items in a list. The items in a list are indexed in exactly the same way as characters in a string. Indexing starts from 0, and the last index is the length of the list minus 1. So here we have a list called points. It stores integers, and first index has 10, then 9, then 10, then 8, 7, 7, 10, 7. And this is how each item in a list is mapped to its index. So item 10 is index 0, item 9 is index 1, and item 10 again is index 2, and so on and so forth. So this list has, 8 items, but as you can see, 8 items, but as you can see, the final index is the length, right? The number of items in our list minus 1. Because again, in Python, just in programming in general, we are 0 indexed, meaning we start counting from 0 when we're tracking positions. And so when we start at 0, that means the highest number is going to be 1 minus the size or the length of our list. So that's why the final item here is mapped to index 7 instead of index 8, right? If we were to do points and then square brackets and then we put in an 8 here, you're going to get an index out of range error or something along those lines. I don't know what it's called specifically in Python. But if you work with Java, JavaScript, that's a common error when you're trying to access an index in a list that is out of bounds. You get an index out of bound error. Okay, a single list item can be accessed just like a single character in a string is accessed, with square brackets. We have a variable here called myList, and it's initialized with this list that has integers. We've seen this before up above. So if we wanted to access the first item in this list, we do myList followed by square brackets, and then inside we put index 0, which will point to the first item. If we wanted to access the second item, we'll do square brackets and pass 1 into the square brackets. If we wanted to access item number 5 here, or the index that contains this value of 5, we know that's index number 3, right? Because 0, 1, 2, 3. And so we can access it by passing 3 to our myList variable with the square opening and closing brackets. So if we print myList 0, that's going to give us 7. If we print myList 1, it's going to give us 2. And if we print myList 3, it's going to give us 5. Here they're doing print, they are calling the print function, and they're passing in this string that says the sum of the first 2 items, and then comma, and then they're adding the first 2 items in our list, which is 7 and 2, which is going to give us 9. So here, when we print the first item, 7, the second item, 2, the fourth item, index 3 is 5, and then the sum of the first two items is 9, right? Because 7 plus 2 is 9. The entire contents of the list can also be printed out. Again, we have myList here, and we can just do print, and we can call the print function and pass myList into the function, and it's going to print out our list with the opening and closing square brackets included. Unlike strings, lists are mutable, which means their contents can change, right? You can't, with a string, you can't do, string square brackets index 0 and change that to a different letter, right? What's in that position, what's in that index when it comes to strings cannot be changed. You have to override the entire variable to store a new string or to replace a certain character in that string. Right, so unlike strings, lists are mutable, which means their contents can change. You can assign a new value to an item within a list, just like you can assign a new value to a variable. So here we have myList. Again, it's a list of integers. We can print myList as we did up here. And then we can do myList at index 1 and change that to 3. So here currently our myList is 7, 2, 2, 5, 2. But when we do this, then it's going to be 7 followed by 3, then 2, then 5, then 2. So when we print myList again, it's going to be at index 1, this value is going to change to a 3. So this is how the program will execute. Right? So originally our list has 72252. We update the item at index 1, change that to a 3, and so then our list becomes 73252. The function len gives you the number of items in a list, right? This is the length function, as we've seen with strings in the past. It returns the size of the list. So if I do print and I pass in the length function and then we pass in the list between the parentheses of the list as an argument for the length function, it's going to give us the number of items inside our list. So we have 5 items in this myList variable. Okay, so here we have our first exercise. If any of this didn't make any sense, let me know in the comments and I'll try to go over it in a little bit more detail. But that's pretty much the gist. The way we can interact with strings is very, very close or similar to how we interact with strings, but with a little bit more added functionality. Like, for example, the fact that we can go in and target individual indexes and change what items are inside those indexes. I think that's pretty cool. But yeah, so if you have any questions or if there's something that didn't make any sense, let me know in the comments below and we can go over it in greater detail. Here we have our first exercise of this section called change the value of an item, and I have it here open on VS Code. You can look past in some of the videos that we did, starting from the beginning of chapter 4, on how we learned how to open exercises in VS Code. So I have the exercises here for this section already open, like I mentioned before. So I don't have them all open. Hopefully we can save some memory, as we've seen in previous videos. VS Code tends to eat a lot of memory no matter how lean I run it. Right, if I disable all other extensions that I have installed that help me with developing and programming for work and whatnot, it still takes up a lot of memory. I don't have a lot of RAM on my machine, so I'm running it pretty lean, as you can see. There's no theme coloring going on or anything like that. All right, instructions are say please write a program which initializes a list with the values 1, 2, 3, 4, 5. Then the program should ask the user for an index and a new value. Replace the value at the given index and print the list again. They should be looped over until the user gives -1 for the index. You can assume all given index values will fall within your list. An example execution of the program, right? We prompt the user to provide an index. They provide index 0, and then we prompt them to enter the new value. Then it's going to change our list at index 0 to have 10 instead of 1. So it's going to be 10, 2, 3, 4, 5, and it's going to ask for another index, and so on and so forth. So we know that we're going to use a loop, and the only way to break out of this loop is if the user inputs the value -1. So we know we're going to need a while true loop, like that. Here we're going to declare a list. Just going to call it my list is equal to 1, 2, 3, 4, 5. Then we're going to prompt the user to enter an index. So we're going to say index is equal to input. In fact, we should wrap this with the integer function so we can convert that input string into an integer. I'm going to call the input function here, prompt them for an index. Okay, and then we're going to prompt them also for a value. So here we're going to do the same thing, integer, input, value, like that. Then what we're going to do is do my list at index is equal to value. And that's it. So in fact, actually, what we should do here is just check if index is equal to -1, then we want to break. Otherwise, do this, and it's going to keep looping us back and forth. So let's run our code. Can't see the run button up here. Give me 1 second. Okay, so if you don't see the play button up here, I think it's probably because I'm zoomed in, but if you don't see it, down here in the terminal when you open your workspace, it should point to whatever folder, whatever exercise folder that you have open. So what you can do is check if you're inside the source directory, or if the source directory exists inside that folder. You can type dir. It's going to print out all the directories that are available inside this folder. So we have the source, test, and TMC. The TMC folder is invisible, but it is inside of this folder. So what I'm going to do is change directory into the source folder like that. Then I'm going to hit right clear here. It's going to clear our terminal a little bit, give us some working space. Then what I'm going to do is I'm going to write Python and then write the name of the file. So the name of the file here is change underscore value underscore of underscore item dot py. Hit enter. It's going to run our program for us. So now we can test our code manually, right? I can do index 0 and then pass in 10. Oh, when I forgot, we need a way to, once we change that value here, we need to print my list so we can see that it's been updated. Okay, so I'm gonna exit out of that, hit clear, and if you do up or down on the arrow key, it's gonna show you all the different commands that you've already inputted into the terminal. So the last command that I entered here was clear, right? If I hit up, it shows me the clear command that I entered. If I hit up one more time, it's gonna show me the Python, us running the file here manually using Python. So I can, instead of having to type everything out, I can just do that, hit enter again, target index 0, put in 10 for the value, and as you can see, it's printing 10, 2, 3, 4, 5. Okay, it's asking us again for the index, just like what we're expecting it to do here in the example execution. Gonna target index 2, give it a value of 250. Now, okay, now this is a problem. 1, 2, so it's only changing it while it's looping. So we might have to declare this variable outside, right? Because, and that's what I should have done, because each time the loop runs, right, it's resetting my list back to its original values of 1, 2, 3, 4, 5. So when we declare it outside of our loop, then this is its original state. Inside the loop, we're going to keep updating that original one, so we don't have to keep resetting it over and over when our loop runs. So again, I'm going to hit Control C on my keyboard. I'm going to hit it twice, type clear, run our program again. Okay, index 0. It's going to change that to value of 10. So now we have 10, 2, 3, 4, 5, like we do over here. Index 2, we're going to change it to 250. Now we have 10, 2, 250. As you can see, 10, when we changed index 0 to 10, it remained when we run our loop again. Now index 2 is 250. Okay, we can target index 4, enter negative 45. So we're expecting that the last value in our list is going to go from 5 to negative 45. Okay, we enter that and we can see, again, when we change index 0 to 10, it remained. We change index 2 to 250, it remained. Now index 4 is minus 45. And when we type in negative 1, okay, it's not breaking. So let's go back into our code and check why that is. So because we're assigning the value immediately after, we're automatically prompted to enter the value. So we need to move this down past our if check here to make sure that we first check if the index is equal to negative 1 before we do anything else. If index is not negative 1, then proceed to prompt the user to input whatever value they want to change their desired index to. But if they do enter negative 1, then we want to break out of the code. So we're going to close that up one more time, run our program one more time. Index 0, change that to 10. Index 2, change that to 250. Index 4, change that to negative 45. Okay, now when we enter negative 1, there we go. Our program exits. So that should be the solution. Over here, they have a note saying this exercise doesn't ask you to write any functions. Correct, so you should not place any code within an if name equals main block. So we don't need to worry about writing this as we've done when we're working with functions. All we need to do is hit our run tests button up here. Let this do its thing. There we go, our tests passed. Send solution to the server so we can get credit for our solution. And there we go. Hit the refresh button and we have on the browser and we have credit for doing this exercise. Feel free to open the model solution in the browser. I'm not going to do it, just, actually, you know what, I'll do it. I mean, the solution is going to be the exact same as this because this was a pretty easy exercise to take on. But I'll demonstrate it for the sake of keeping tradition. So give me 1 second, let me log into the TMC website on the browser, and then we'll look at the model solution. Okay, open the solution on the model solution on the browser here. Let me just zoom in a little bit. So they have a variable here. They declare their list outside of their while true loop, just like we did. Initialize it with the integers 1 through 5. Then they have the while true loop. Okay, prompt the user to input their index. If index is equal to -1, then break, just like what we did. What they also did is made sure that whatever index that we target is within bounds, right? We don't want to access an integer, right? Like index number -1 or index that's our array here has, our list here has 5 items. We don't want to access index number 6 or number 7 or anything that's beyond the size of the list itself. So this is actually very good to do. In fact, we're going to implement that. We're just going to copy this because it's actually a really good idea, right? Check if the index is not out of bounds, and if it isn't, then prompt the user to input the value. Then we want to update that index in the array, and here we need to change this to my list because that's what we called our list variable, and then print the list after we update that value, that index value, from our original array. And that's it. That's the solution. Again, you can submit this solution if you want. Again, I think this was a really heads up thing to do. So that's the model solution. It's identical to what we did, with just the added check for when an item might be out of bounds. And again, just to make sure, if you look on the Explorer here, when you open it, you should see this little green dot indicating that you've gotten credit for this exercise, and the exercise is marked complete. So you can go ahead and close this file. You can collapse this folder. I'm just going to go ahead and pre-fire this second exercise from the section here, and we'll get to it when we get to this section. I'm going to close this sidebar for now. We're not going to need it. All right, adding items to a list. The append method adds items to the list to the end of a list. It works like this. Here we declare a variable called numbers that is assigned this empty list. Okay, all right, array is called numbers. We can do numbers.append, and we can pass a integer into as an argument into the append function that's again exists natively with lists. So once we declare a list in Python, then we have this append method that's available to that list. So append will add items to the end of a list. So when we do .append and we pass 5 into this method, into this function, it's going to add that value 5 into our array. When we do append number 10, append 3, it's going to add 10 and 3 to our array. And then when we print the numbers list, again, I keep calling it an array, a list. I want to be very thorough here. Lists in Python. I got to get that squared away in my brain. When we print our numbers list, it's going to show 5, 10, and 3. The following example makes use of 2 separate lists. Here we have one list called numbers and another list called shoe sizes. Both are initialized as empty lists. We append 5, 10, and 3 to the numbers list. We append 37, 44, 40, and 28 into the shoe sizes list. Here we print numbers. We print the numbers list. Here we print shoe sizes, and we print the shoe sizes list. Right, so the item is appended to the list on which the method is called. Right, so we called append on the numbers list here 3 times, and then we called append method 4 times to the shoe sizes list. So that's how we appended these values to the shoe sizes list, and 5, 10, and 3 to the numbers list. Okay, very simple. Append method exists natively, right? It's one of those built-in functions to this list data type in Python. Okay, this exercise is called add items to a list. We already have it open here in VS Code. We're instructed to please write a program which first asks the user for the number of items to be added. Then the program should ask for the given number of values one by one and add them to a list in the order they were typed in. Finally, the list is printed out, an example of expected behavior. So how many items? We type in 3, item 1, item 2, item 3, and then finally it's going to print that list with the appended items. Again, we're not writing any functions, so we don't have to worry about this. So we don't have to do this if name equals main block trick that we've been doing when we're writing functions. So we're going to declare here a variable called list assign it to an empty list. Then here we're going to prompt the user for how many times we want to iterate this. So we can call it items for now. But if you come up with a better, more you know, logical name for this variable, you can call it whatever. But we're going to prompt the user to tell us how many items they want to pass into our list, and then for that we're going to do a while items is greater than 0. Then what we're going to do is item, set that equal to an integer, item 1. So in fact, we'll just do item 1 here. In fact, actually what we could do is set that I equal to 1. And then here we can do let me not overcomplicate this. Item 1, item 2. Actually, no. That's give me 1 second. Let me think about this, because I want us to be able to increment this in an intuitive way. Give me 1 second. Let me think about this, because I have this idea in my head and I'm struggling to put it down to paper. Okay, so there's a way, and I don't remember if we learned this, but this is one of those things where if you do some research and you're curious, there's a way that you can use F strings in input statements. So normally when we want to input take a user input, but we want to prompt a user for that input, we do something like this. Value is equal to, and we want to get an integer, for example, or let's just we want to get an input. We can do this, right? Item 1, for example, like that. And we are typecasting this to an integer value, so we want to take whatever input we're getting, which is going to be automatically a string. We want to convert that into an integer before assigning it to the value variable. Now, what happens if we want to do something like this, where we need a loop and we need a way to print an incrementing number like this while printing it in the prompt for the input value? So what I'm going to do here is declare a variable called index, and I'm going to set that equal to 1. And here we have our list variable, set that equal to an empty list. And then we're going to prompt the user here for how many times they want to loop. So we're going to say items is equal to input, how many times. And again, we want to make sure that this is saved as an integer so we can use it in our loop. So we're going to cast that to the integer data type like that. Then what I'm going to do is do while index is less than or equal to the items. We want to prompt a user to give us a value. Now, how can we iterate? As you can see here, it's asking item 1, item 2, and item 3, but we need to be able to do this in a way that we're not storing value 1, then value 2, like this, value 1, value 2, value 3, like this, right? Because we want our loop to run 3 times, and each time to do one thing: prompt the user for a value, append that value to our empty list. So what we can do here is use F strings. Yes, we can pass F strings into the input function to style how we want to print our items. How do we want to print our inputs? So now what we can do here, using curly braces, is pass index. Since index is going to be initialized as 1, this is going to print item 1. Okay, and then what we're going to do is do list.append value. I'm going to call this value 1. I'm just going to call it value. And then our loop is going to run again. In fact, here I need to increment index by 1, index plus 1. So then our loop is going to run again. Index is going to become 2. So this is going to print it's going to print item 2. And then we can input whatever we want. Then it's going to append that second value into our list. And it's going to increment index by 1, and then it's going to print it one more time. So that's if we were to call our loop 3 times. So this is what I wanted to demonstrate, but I was unsure whether or not we learned this. But whether or not we learned this, it doesn't matter. I'm teaching you guys this right now. Okay, so this is another way that we can stylize the value that we want to give. The value of the prompt that we want to show a user, and also use that in an intuitive way in our loops, so we don't have to declare multiple variables that store different values and then prompt the user that way. We could just do something short like this, and it'll still work. So I think this should be the solution. I've already navigated to the add items to list folder. If you haven't already, so say for example, if you're still here inside the source folder, just do cd, pardon me, let me clear this, just do cd ... It's going to back you up into the part 04 folder, then do cd one more time, so you can just chain them together like that. It's going to back you up into the workspace. Okay, so just to demonstrate, for example, now I'm in the MOOC Programming 26 workspace, and then what I can do here is write cd into part 04-13 underscore add items to list, like that. Press enter. Now we're inside of this folder. Then I'm going to navigate to the source folder. Now I have access to our exercise file. Now I can do Python, add items to list, like that, hit enter, and now our program is running. We're going to follow this expected behavior inputs and outputs here just to stay close to our manual tests. I'm going to type in 3. Now you're going to see what we're doing here, right? How this is going to become item 1, then item 2, then item 3. So item 1 is going to be 10. Now you can see it becomes item 2. Item 2 is 250, and then item 3 is 34. Okay, so our code run, but we forgot to print our list down here, so we're just going to print the list like that. Okay, let me clear this, run our code one more time. I'm going to run it 3 times. Item 1 is 10, item 2 is 250, and item 3 is 34. And there we go. Now it's going to print 10, 250, and 34. All right, let's hit the I button over here to test our code. Solution passed. We can send the solution to the server. And just like that, refresh. We got credit for it. We can take a look at the model solution in the browser as well. And yeah, see, they did the exact same thing. They used f strings as the argument passed into the input function to stylize how we want to show our the prompt that we're showing the user, and also to increment that by 1 so that we can be able to do item 1, item 2, item 3. Now they did item, then using the length of the list plus 1, again because the list is starting off as empty. So in order for this to be printed as 1, we're going to do 0 plus 1, and it's going to be 1 plus 1, and then 2 plus 1, etc., etc. So because as a way to avoid declaring an index variable somewhere over here and using that to increment our this variable, this how we present the prompt. But yeah, so they did the exact same thing. We did it this way. We had an index variable, but they used the length of the list as a mechanism to increment the number of what item that we're adding during each loop. All right. So I'm going to close this folder, open the Explorer here. Again, green dot here means that we got credit for this exercise. I'm going to go ahead and open this folder, this file. And I'm just going to, again, show you here one more time. Going to right clear here. We're still in the exercise 13 folder. So again, if I do type in the directory command here, we're going to see this is the last exercise that we did. And then do change directory, double dots here, periods, which is going to back us up one folder. So I'm going to change that to back us up 2 folders like that. So now we're in the root MOOC programming 26 folder. Okay, I'm going to close that. And if I write directory again, it's going to show us all the exercises that are available. Right now we're going to be doing exercise 14. So I'm just going to copy that, scroll down here, do change directory, paste that, hit enter. Now we're in that folder. And then I'm going to change directory into the source folder so we can run our exercise when it's time to test our solution. Okay, adding to a specific location. If you want to specify a location in the list where an item should be added, you can use the insert method. The method adds an item at the specified index. All the items already in the list with an index equal to or higher than the specified index are moved one index further to the right. So here we have a variable called, a list assigned to this variable points, has these integers 10, 9, 10, 8, 7, 7, 10, 7. Okay, and these are mapped to their respective indexes from 0 to 7. So if we do points dot insert to 2 comma 12, this insert function is again native, or it exists built into list data types. So we provide the index and the value. So what's going to happen is at index 2, it's going to insert the value 12, but it's not replacing what was already at index 2. It's just adding a new entry here and then pushing everything from index 2 originally over by 1 position. So as you can see now, points ends up having 3, 6, 8. Instead of having 8 entries, now has 9 entries. Right? As you can see, our index went up by 1 value. Our final index went up by 1 value. So we had 10, 9, 10, 8, 7, 7, 10, 7. But now we have 10, 9, 12, followed by the remaining parts of our original points list. So now all these from original index 2 to index 7 becomes assigned to index 3 down to index 8. So hopefully that makes sense. The insert function with lists, you give it an index and the value that you want to place there, and it's going to insert a new item at that index and push everything else 1 position down to the right. So if this doesn't make any sense, let me know in the comments and we can go over it a little bit more in detail. So for instance, this program, we have a variable here called numbers. It's assigned a list with these values, 1, 2, 3, 4, 5, 6. Then we say numbers that insert index 0, value 10. So when we print numbers, we're going to see this, 10, then 1, 2, 3, 4, 5, 6. I think this is even an easier way to see it. Right? We insert at the beginning of the list, we insert a new item with the value of 10 in it. So now our our list pushes everything to the right. All the original items move down 1 index, and then we place 10 at the beginning of the list. Here we do numbers that insert 2 and 20, and then we print. So our list currently has 10 at the beginning, and then at index 2, so this will be 0, 1, 2, we want to insert a new item that has the value of 20. And then 2 down to 6 gets shifted 1 position to the right. So now our list is going to say 10, 1, 20, the new index, so the new item we just inserted, and then 2, 3, 4, 5, 6. So this from here to here gets moved down 1 position to make space to insert this item that has the value of 20 in it. Okay, removing items from a list. There are 2 different approaches to removing an item from a list. If the index of the item is known, you can use the method pop. If the contents of the item are known, you can use the method remove. So the method pop takes the index of the item you want to remove as its argument. The following program removes items at indexes 2 and 3 from the list. Notice how the indexes of the remaining items change when one is removed. Here we have a list assigned to this variable mylist, has these integers 1, 2, 3, 4, 5, 6. Here we do mylist.pop 2 and then mylist.pop 3. So what's happening? So when we print mylist and we move 2, we get 1, 2, 4, 5, 6. So 2 is not the value 2, it is the index 2. So it's removing this 3 from our list. That's how we end up with 1, 2, 4, 5, 6. When we say my list pop 3, we go to index 3, so 0, or actually down here, so 0, 1, 2, 3, where the 5 is, we remove that, and then now we have 1, 2, 4, 6. It's useful to remember that the method pop also returns the removed item. So again, we have a myList variable here, stores this list of integers 42725. Here we have a variable called number, and it stores the return value that we get from using the pop function or the pop method on our myList, on our list here. So pop index 2 is going to return this 7. So when we print the number, right, the return number that we store here, it's going to print 7, and then myList is now going to have 4225 printed down here. So we can store the value that is returned when we remove an item from our list using the pop method. The remove method, on the other hand, takes the value of the item to be removed as its argument. For example, this program. So we have a variable here called myList. It's assigned this integer list of integers 1, 2, 3, 4, 5, 6. Here when we do myList.remove and we pass 2, right? Now Python is going to go through our list, find the item with find the index with the item that has a value of 2 and remove that. So when we print myList, it's going to print 1, 3, 4, 5, 6 like this. When we do myList.remove 5, now it's not looking for index 5. It's just looking for an item with the value of 5 and removing that. So when we print myList again, we get 1, 3, 4, 6. As you can see, the 5 here has been removed. So the remove method removes an item that we want by its value, while the pop method removes an item based on its index. So hopefully that made sense. The method removes the first occurrence of the value in the list, much like the string function find returns the first occurrence of a substring. So if we have a repeating number in our list, the remove method is not going to go and remove every single occurrence of that number in our list. It's only going to remove the first one it finds. So here we have my list has these integers 1, 2, 1, 2. We tell Python to remove item 1, right? An item or whatever 1 appears in our list, go ahead and remove it. Python goes scans our list and says, hey, index 0 has an item that has the value of 1. So it removes that. But when we print my list, it prints 2, 1, 2, right? Because 1 exists again or appears again later in our list. Python is not going to worry about that. It's only going to find the first instance that that value appears in our list and takes care of that. When we do my list that remove 1 again, it's going to, now our list is 2, 1, 2. It's going to check first index. It's a 2 here, so it doesn't worry about it. Checks the second index. There's a 1 here. It's going to remove it. It's going to keep the remaining 2 here. It doesn't worry about anything after than that. It found its first occurrence here, and that's all it's worried about. So now my list, when printed again, prints 2, 2. Okay, this is our next exercise called addition and removal. And we're instructed to please write a program which asks the user to choose between addition and removal. Depending on the choice, the program adds an item to or removes an item from the end of a list. The item that is added must always be 1 greater than the last item in the list. The first item to be added must be 1. The list is printed out in the beginning and after each operation. Have a look at the example execution below. So we first print our empty list. Then we prompt the user to either add or remove or exit. They decide to type in D, which is going to add. So it's going to add 1. Okay, then we're going to prompt the user again, and choose to add. So it's going to automatically add a 2. And then again, I choose to add, it's going to keep adding 3. But when we choose to remove, it's going to remove the last index in the list. So our list at this point has 3 items in it, 1, 2, and 3. When we did remove, it removed that final index. So now it's back down to 1 and 2. And here we have 1, 2, and 3. When we add it again, and then we can exit this by typing an X. So here we're going to declare a variable called list, set that to an empty list like that. And then here we're going to do a while true loop. And we're going to print the list. But we're going to have a little sentence to go with it. So we're going to say the list now is like that. I don't know why I wrote lint here. It's list. And I'm just going to break. We're just going to test this to see it's going to print our empty list as the first thing it does. Addition and removal.py. Now just press the list. The list now is empty. All right, cool. So then we're going to prompt the user for an action. We're going to say input. I'm just going to copy this like that. Then we're going to check if action is equal to X, we're going to break. Else if action is equal to D for addition or to add an item, then what we're going to do is do list.append. In fact, here we're going to track index or just I. So I equal to 0, list.append. I should set it equal to 1. List.append I. And then else if action is equal to R, forgetting colons here. I'm going to do list.remove, list.length, or it should be length of list minus 1. So it'll be the last item in the list. Actually, no, not remove. It should be pop, right? Because pop takes in the index. Okay. Then here we're going to do I is equal to I plus 1. And then once we break out of this loop, we're just going to print by, like that. So let's run this and see how we do. Python addition removal. The list is now empty. Okay, we want to add. The list is now 1. We want to add again. Okay, so this is not I is equal to I plus 1. Okay, so I is being reset. So we need to declare I outside of our array here because I keeps getting reset to 1. Okay, so let's do this again. Let's run our program one more time. So we do D. List is now 1. Add again. List is now 1, 2. Add again. List is now 1, 2, 3. Remove. List is now 1, 2. Add again. List is now 1, 2, 5. Okay. So remember, pop returns the value that we just removed. So here what we should do is set index equal to list.pop. But it's still going to increment our list here by 1. So maybe what we should do is set index equal to 0. Increment I early, like that. So let's see what this happens. Okay, let's now, so we want to add, remove, add again. Okay. It shouldn't print 5. It should print 3. Okay, so This is, I went back and scrolled up here just to see, but they didn't they didn't talk about this. This is a useful thing, and I guess maybe they might cover it in the actual lecture videos that the university produces. But again, this is one of those tricks I'm just going to teach you because you're more than likely going to use this in the future when you're writing your own programs beyond this course. So there's something. So let's look at the instructions here one more time. Okay, so when we remove from from our current list, we always removed the last index in the array, right? And here, so far, we're using the pop method, but we're passing it the final index. Now the problem here is we're using this tracker variable, this iterator variable here to track the index. To append, but we're not using it when referencing what we want to pop. So what we can do actually entirely is we can just rely on the length of the list when it comes to appending and removing items from this list, so we don't encounter this problem where index still increments while we want to append an additional value here that is only one value larger than the previous value, right? We want to map the values of each index to the size of the list. So what we can do here is we can remove these two lines like that. And then what we can do, instead of appending, since our list is always going to be 0, it's always going to be initialized empty first, what we can do is get the length of our list and then plus 1. So this is going to return 0 plus 1. So so remember, append always adds to the end of the list. So when the list is of 0 length, we're going to add to index 1. We're going to add at index 0 the value 1. So let's see this in action. I think it might be easier to see. So let's run our program here. So if I hit add, we get 1. If we add again, we get 2. If we add again, we get 3. So we're relying on the size of the list to help us add one number larger than the previous item in the list. So hopefully that makes sense. Now, how does this help us when it comes to removing an item? Well, the pop function, or the pop method with lists, takes in an index, right? So here, for example, we're providing the last index. So, in fact, I think this should work. Let me see. Right, so this actually still works. So we don't even need to change anything else. We had this correct. We don't even have to. So we just removed needing to use the index variable. So if I do this and I do remove and I do remove again and I add again, it goes back up to 2 and 3. So we don't even need to use the index variable here. We can just rely on the size of the array to when we're appending items and when we're removing items. What we can also do here is, instead of passing the last index, we can just pass an empty pop variable like this, right? And it will still do the same thing, but we don't have index. We can just do this. I think this will still work. So if I run this, add, remove, add again, and it still works. So with the pop function, if we don't pass a value, right, an index in here, it's going to automatically just go and remove the last item in our list automatically. Now, this is cool, but what happens if, for example, we run this program and we remove immediately? Well, that's going to be a problem. We need to just make sure that our list has something. So we're going to say if the length of the list is greater than 0, then you can list that pop. Otherwise, don't do anything. So it's just going to skip this. I think we can do continue here. And Actually, we should probably do else continue. And I think this will work. So let me save this, clear here, run our program again. So if I remove, now it's looping. So now we're telling, hey, Python, if our list is greater than 0, this is a great check. You should always, for in this scenario, I think this is a good check to have, right? Make sure we can only remove if our list actually contains items. So if I was to add something here and then remove, and now it works. But if I was just to remove something off rip, it's going to keep asking, just going to show us an empty list over and over and over again. I can do this a million times. Then I can add a bunch of values here, and I can remove them again, right? And add and back and forth, and we should be good to go. So let's run this through our tests, see how we do. Okay, we failed. The list is now on row 1. Your program should print out the list is now an empty bracket. But now it prints the list. Okay, so this is just an error here. So instead of the list is now, I printed the list now is. Okay, that's the only error here. Let's run our tests again. There we go. We passed all the tests. Send our solution to the server. Refresh. Get credit for that. Take a look at the model solution on the browser. And there we go. Well, so this is what they did. They do while list. They declare an empty list. Use a while true loop. Print the list is now. Print that empty list. Then they prompt the user for an action. If they select D, append. You see the same thing here. They used the length of the list, and they did it in 2 lines. We just did it in 1 line here. And then they checked if to remove. So they again passed the final value, index here to the pop function. Right? You can do this, or you can do it like this again. Length of list -1 to get the last value. So I'm just going to comment this out, which is what we did down here. Just going to comment that out. You can do it this way, right? If you don't pass a value to the pop function when you're working with lists, it's going to automatically remove the last item, or you can specify the last item in the list by passing this into the pop function. So this is what they're doing here. Only thing that they didn't do is they didn't check if the list is empty, right? If the list is empty, we don't want to take out anything, right? So here we can actually write a comment here for ourselves. If list is empty, don't remove anything, and save, so we don't get any errors or some index out of bound ranges and whatnot. Otherwise, if it's X, exit out of the loop, and we did that as the first step. And that's it. So that's the solution. Again, all solutions will be put up on GitHub. You can view the solutions to all these exercises later as a form of review. They'll be up on GitHub. The link will be in the description below. Okay. If the specified item is not in the list, the remove function causes an error. Just like with strings, we could check for the presence of an item with the in operator. If 1 in my list, then print the list contains item 1. If 2 in my list, print the list contains item 2. So I guess this is if someone is using the remove function. Okay, here we have another function. Others. Let me just set up these files here. Give me 1 second. Okay, so I just opened exercise 15. Again, we got credit for this past exercise here. I'm going to close this Explorer. I've already navigated to the folder inside the terminal here. So I'm not going to do that on video, but you can go ahead and do that on your own. We have an exercise here called Same Word Twice. We're told to please write a program which asks the user for words. If the user types in a word for the second time, the program should print out the number of different words typed in and exit. So here we're going to do word once, then word upon a time. You typed in 4 different words. If this exercise doesn't ask you to write any function, so you should not place any code, blah, 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 blah. So here we're going to have a list, set that equal to an empty list, while true value is equal to input word. Then we're going to say list.append word. And we're also going to have index here, set that to 1. And then we're going to increment index by 1. And then if value in list break, otherwise append that word and increment. Then we're going to print you typed in, actually we should use an F string here, index different words, like that. So let's run this. Python same word twice.py. Okay. Okay, let's run this again. Oh, you type passing value, not word. Okay, let's run this again. So once upon a time upon 1, 2, 3, 4, 5. You typed in 5 different words. So actually, what we should do, instead of do this or have an index, is just get the length of the list here, like that. Let's run this again. So once upon a time upon. There we go. You typed in 4 different words. Let's test this. There we go. Send that solution to the server. Okay, refresh. We got credit for it. See the model solution in the browser. There we go. They have an empty list of words. Okay, grab the word. If word is in words, break. Otherwise, append. And then print out the final sentence here. So exactly as what we did. We can just add some spacing here to make it look a little bit better, but that's the solution for this exercise. Okay, I'm going to close that. I'm going to navigate to the next exercise in VS Code off camera, and then we're going to continue reading from here. So give me 1 sec. Okay, sorting lists. The items in a list can be sorted from smallest to greatest with the method sort. So here we have a list of integers assigned to this variable myList. It currently has this integers 2, 5, 1, 2, 4. It's unordered, right? There's no rhyme or reason here. It's just random listing of integers. When we call the sort function on our list and print our list, now our list is ordered from smallest to largest value. Notice, so we go from random 2, 5, 1, 2, 4 to now 1, 2, 2, 4, 5. Notice how the method modifies the list itself. Sometimes you don't want to change the original list, so we use the function sorted instead. It returns a sorted list. So we can still manipulate our list, but indirectly, right? Basically, what this is doing here, when we use the sorted function, is it makes a copy of this array of this list, then sorts it, and then returns that copy array. And then we can save this, right? Because it's a returned value. We can save this to another variable. So remember the difference between the two. Sort changes the order of the original list in place, whereas sorted creates a new ordered copy of the list, which is what I was just talking about. With sorted, we can preserve the original order of the list. Now, you might wonder why we need to preserve the order of our list. Maybe in your function or your program that you're writing, you might need to compare the two. So you don't want to update our original list, because then we won't be able to use it to compare. So we can use the sorted function to make a copy of this, sort it from in ascending order, and then we can compare the two. So if we want to compare indexes, like, hey, is the index 0 the same on these two lists, et cetera, and things like that. So that's the flexibility that it gives you. Okay, we have an exercise here called list twice. It says, please write a program which asks the user to type in values and adds them to a list. After each addition, the list is printed out in 2 different ways: in the order the items were added, and then ordered from smallest to greatest. The program prints exits when the user types in 0. An example of expected behavior. New item 3, the list is now 3. The list in order, 3. New item 1, the list now is 3, 1. The list in order, 1, 3. New item 9, etc., etc. So every single time we add it, we print the list unordered and the list ordered. So here we're going to have a variable called list, set that equal to an empty array. While true, then we're going to prompt the user for a value. Then we're going to check if value is equal to 0, break. And when we break out, we want to print by. Okay, once we pass that check, we're going to print our list. So print the list now, list. Okay, and then print the list in order, sorted list, like that. And I think that should be it. Oh, that's not true. So we want to append value to our list. So we never print the empty list. We just print once everything has been started happening here. Okay, so let's do Python list twice.py. Okay, new item 3. The list now contains 3. The list in order also contains 3, just like what we see here. We add 1. So now here the list 3, 1, 3, 1, and the list in order is 1, 3. We add 9. We get 3, 1, 9 as we do here. We get 1, 3, 9 as we do here. We add 5. We get 3, 1, 9, 5 as we do here. And then we get 1, 3, 5, 9 as we do here. And then when I pass in 0, we exit out of the loop and we print by. So I think that should be the solution. Run our tests and our tests pass, send that solution to the server. Refresh, we got credit. We can view the model solution in the browser as well. And there we go, they have an empty list. They have a while true loop. Prompt the user for a value. If the value is 0, break. Otherwise, append that value to our list. Print the original list. Print the sorted list. And if by any means we hit this terminating condition and break out of a loop, print by, just like what we did in our solution here. Awesome. I'm going to close that. I'm going to navigate to the next exercise, and then we're going to continue. Okay, just keep making sure that you're keeping track of these indicators here. We have 5 green dots so far. We did exercise 12 to exercise 16. Gonna close this, and I have exercise 17 open here called length of list. Gonna close the sidebar here, and I've already navigated to this exercise folder here as well, so I have that prepared. And so let's do this quick readings, and we should have the remaining 3 exercises to do to get to the end of this section. So hopefully we can get this done by the time we hit the 1.5 hour mark. Okay, maximum, minimum, and sum. The functions max and min, short for maximum and minimum, return the greatest and smallest item in a list respectively. The function sum returns the sum of all items in a list. So here we have my list. It's this integer list, 5, 2, 3, 1, 4. We have a variable called greatest. We use this max function, pass in our list. It's going to return the largest value in our list, which is 5. Smallest, we call this min function, pass in our list. It's going to return the smallest value here, which is 1. Then list sum, we call this sum function, pass in our list. It's going to return the sum of all these items in our list. So when we print smallest, we're going to get 1. When we print greatest, we're going to get 5. When we print sum, we're going to get 15, right? Because 5 plus 2 plus 3 is 10, plus 1 is 11, plus 4 is 15. Okay, methods versus functions. There are two different ways of processing lists in Python which can get confusing. For the most part, you will use list methods such as append and sort. They are used with the dot operator on the list variable. So for example, here we declare an empty list. Then we can call the append function by doing mylist dot append. And we can pass in the value that we want to append. We can also call the sort method, which is going to sort our array in ascending order. So this is another method call. Some functions are happy to take a list as an argument. Above we saw the functions max, min, length, and sorted do just that, right? Max, min, length, we pass in our list as an argument. This is like when we do with the print function, right? We can pass in a string as an argument, or we can do comma separated arguments here. We can pass in a string, we can pass in a variable to the print function. So that's what we're doing here, almost similarly, but it's just that the max, min, and length do different things. But the way we use them is similar to how we use the print function or the input function or the integer function, things like that. So here, right, greatest is 1 from our original list. Smallest is 1, greatest is 7. The length of the list is 4 items, so it's going to return 4, right? We're printing length here by calling the length function. We've also used this with strings in the past. And we can also just print the array, the list here, by using the print function. Okay, here we have a list as an argument or a return value. Just like the built-in functions above, our own functions can also take a list as an argument and produce a list as a return value. The following function works out the central value in an ordered list, also called the median value. We define a function here called median. We get an ordered list, right, by using the sort function. Then we get the list center by taking the length of the list divided by 2, and then we floor it. So this is the floor function, meaning that the integer division operator here returns a whole number. And then we return the ordered list, and then we try to get that median. The function creates an ordered version of the list given as an argument and returns the item in the very middle. Notice the integer division operator, the double forward slashes used here. The index of a list should always be an integer. The function works like this. Here we have a list called shoe sizes. We want to get the median, right, the number in the middle here. So we can print that here. So we order this list, so it's going to be 36, 39, 40, then 44, 45. So 40, that's why it's returning 40 here. Here we have a list called ages. We have 1, 56, 34, 22, 5, 77, and 5. We're trying to get the median. How many values do we have? 1, 2, 3, 4, 5, 6, 7. When we order this list, it's going to be 1, then 5, then 5, then 22, then 34, then 56, then 77, and then 22 is going to be that middle value. So that's why it's printing the median of ages is 22. Okay, a function can also return a list. The following function asks the user to type in integers and returns the input as a list. Here we define a function called input numbers. We declare an empty list. Then we have a while loop. We prompt the user to input a value. Okay, if the length of the user input is 0, then we want to break out of this loop. Otherwise, we want to append that input as an integer to our numbers list, and then we want to return that list once we finish looping through our doing our loop here. The function makes use of a helper variable numbers, which is a list. All the numbers typed in by the user are added to the list. When the loop is exited from, the function returns the list with the statement return numbers, calling the function like this. So here we have numbers. We call the input numbers function. And then when we print the greatest number is, we can call the max function on our numbers because input numbers returns a list, which is being assigned to this numbers variable. And then we can also call our median function here. So this could print, when we do this, it's going to do all this looping in here. Once we type in the value, it's going to break us out of the loop. Then it's going to print the greatest number, what we called here, and print the median number, what we call here. The small example demonstrates one of the most important uses of functions. They can help you divide your code into smaller, easily understandable, and logical wholes. A Of course, the same functionality could be achieved without writing any of our own functions. Right, we can just use our loop here to manipulate our numbers list to append values. Then we can call the sorted function, store that sorted list into this variable. Then we can get the center of that list by just doing this. And then we can also get the median by calling our sorted list and then passing in that list center that we just got from doing this operation here. Then we can print the max and we can print the median just like that. In this version, following the programming logic is more difficult as it is no longer clear which commands are part of which functionality. The code fulfills the same purposes, reading in an input, calculating the median value, and so on, but the structure is less clear. Organizing your code into separate functions will improve your program's readability, but also make it easier to handle logical holes. This in turn helps you verify that the program works as intended, as each function can be tested separately. Another important use for function is making code reusable. If you need to achieve some functionality multiple times in your program, it is a good idea to create your own function and name it appropriately. So here we can have a function that adds numbers to a list. Same thing here, right? Same thing here. Because this returns a list, so we can assign that to a variable. And also, this idea of breaking our code into functions when we want to do reusability is great because it leads us into another topic of self-documenting code, writing clean code, in the sense that we want to write functions that do one thing, right? For example here, this function input numbers has one responsibility, and that is to add values to a list and then return that list. The median function that we've seen up here somewhere, right? Its whole job is to get you the median value of a list, and so on and so forth. So that's just one of those things where writing functions helps you achieve logical holes and lets you keep things more focused by handling only specific tasks. Okay, here we have a exercise called arithmetic mean. It says please write a function named mean, which takes a list of integers as an argument. The function returns the arithmetic mean of the values in the list. So here we're going to define a function called mean. It's going to take in a list. Remember, we can do type prompting in Python by doing this, as we can see it somewhere. Actually, this was a wrong function here, but where is it? It was defined somewhere over here, but they showed it as an example. But yeah, so we're type prompting here. It says please write a function. So I was reading the wrong exercise. It says the length of a list. Please write a function named length, which takes a list as its argument and returns the length of the list. Just like that. And here what we're just going to do is return length of list. So for example here, we can define a variable called myList, which has these integers. The result is going to be calling that length function, passing in the list, and then printing that result. So the length of this list is 4, and the length of this list is 5. The length of this list is 4. Okay, so I think that should just be it. Let's run our code here. Python length of list.py, and it returns 3, but it needs to print the length is like that. So let's run this again. Okay, so let's run this through our tests. There we go. Send that solution to the server. Refresh, we got credit for it. There's no model solution here for us to look at because this is such a simple exercise for us to do. Oh, actually, there we go, it loaded. Let's look at the model solution. I was assuming there wasn't going to be any because this is how straightforward this is, but let's see how overcomplicated this is, and it's not at all. They do the exact same thing as we did. They do type prompting here, like that, and then return the length of the list as we did in line here. And yeah, that's it. Okay, here we have another exercise here. Let me navigate to this exercise file in a second. Okay, we're being instructed to please order a function named mean, which takes a list of integers as an argument. The function returns the arithmetic mean of the values in the list. Okay, so here we just define a function called mean, which takes in a list. But for the sake of clarity, let's write it like they do in the model solution here, because we don't want to write list and then type prompt as list as well. It could be a little confusing. You don't know which side of this colon is referencing the actual data type that we're going to be working with. I mean, the actual thing that we're going to be working with. Okay, so we want to get the mean. So we're just going to do sum is equal to, call the sum function, pass my list, and then we're going to return the list sum divided by the length of the list. I'm sorry, of my list, like that. So let's run this. And this needs to print mean value is. So I'm just going to go ahead and do that here. Okay, let's run our code here. Python mean.py. When we do this, let's pass these same values just for, and there we go, we get 3.0. Let's run this system tests. And we pass, send that solution to the server. Refresh, we get credit for it. Take a look at the model solution in the browser. And yep, so they just did it inline, so you can even do it more shorthand than what we did here. Just return sum, right? Use the sum function on my list to get the sum of all the values from our list. Divide that by the length of the list, and that's going to give you the mean. Okay. Now we're going to take a look at the final function here. I'm going to navigate to this, exercise here. I'm going to navigate to that folder. I'm going to do it on video because we're at the end of this section. I'm going to change directory. I'm going to back up twice, then navigate to part 04-19 underscore range underscore of list / source. So now we're here. Well, we're in this folder, inside of that folder. And then we're instructed to please order a function named range of list, which takes a list of integers as an argument. The function returns the difference between the smallest and the largest value in the list. So here, my list, with a clear variable called my list, has its integers. Then result is equal to the range of list. We pass in my list, and then the range of list is 4. So the range of list takes an integer as an argument. The function returns the difference between the smallest and the largest value in the list. It's going to do 5 minus 1, which is going to return 4. Okay, so define function here called range of list. My list, which is a type of list. Then here we're just going to get the maximum. So we're going to return max. My list minus minimum my list. Okay, and that's being returned. So we should see, for this example, for example, we need to print that. It should return 2. Or it should be actually, that's a good, I'm curious about this. So let's see this in action. So going to do 6 minus -4, which should be a positive number, but that's not going to be the range. Right, so it brought us a positive number. Well, I'm assuming the range here should be -10, right? No, it should, actually no, this is true. Right, the difference from the smallest number to the largest number is 10. From -4 to 0 is 4 numbers. From 0 to 6 is 6 numbers. I think they should be correct. But for the sake of testing. In fact, let's do this. I'm going to comment this out. So we just keep it as original just in case. Okay, let's run that. Okay, so this we get the same output. Let's run our tests here. Okay, that passed. Send that solution to the server. There we go. Refresh, and we got credit for that. Make sure I refresh for the other two exercises that we did. Let's look at the model solution in the browser. And there we go. They did the same thing that we did over here. Let me close this. Return maximum value from our list minus the minimum value in our list. And that's the answer. And we can print this out finally down here, and that's it. So that's it. That's this section on lists. Here it says there are many more ways to use lists in Python. The Python documentation is a good place to start if you want to know more. Again, if you want to know all the other functions, right, all the other functions that come with lists in your terminal here, do that, type that in. Oh, I'm sorry. I need to first start Python in the terminal, and then I can do that. And these are all the different functions that we can use. These are the built-in functions that are come with this list data type. But again, we also have access to the max, the min, the sorted functions, and so on and so forth. You can also do this for any other data type. For example, strings. It'll tell you what variables come built in with the string data type. You can do it with integers, right? Okay, this is integer, is a denominator, conjugate, bit length, etc., etc. So I hope this video was helpful. If you have any questions on anything that we covered in this video, please leave it in the comments below. I will try to get to you and help you out to the best of my knowledge. In the next video, we're going to do section 4 on definite iteration. That will probably be posted on Thursday or Friday. I hope to put up at least 2 to 3 more videos by the end of this week. So I think we might be able to get through this whole section by the end of this week. If not, by early next week, we should be doing this last chapter, this last section here. And then we can start chapter 5 and hopefully be done with part 7 before June starts. So again, if you've been enjoying these videos, please give it a thumbs up. Like, share, comment, subscribe. Thank you for all the support. I've been getting so many comments of people letting me know that they appreciate the videos and they find them useful. So I'll keep pumping these out as often as I can. We didn't lose as many frames today. So somewhere I did something right in setting up VS Code and OBS together so my memory doesn't get eaten up. But again, if you enjoyed this video, please give it a thumbs up. Please subscribe. It truly helps me out. It gives me the motivation to keep going. All solutions to all the exercises that we covered here will be in the description below. I will also try to go through the video and add timestamps. So if you want to go straight to the exercises, you can go through the timestamps. So that might be helpful for you if you don't want to hear me waffling on and reading some of the source content here. That's, the source material from the course itself, and just want to see me covering the exercises. But yeah, I'll see you guys in the next video. We're almost there. We're almost done with part 1, this introductory part. And so when you finish with that, you can go ahead and take the exam and see how you do and get your certificate of completion. All right, I'll see you guys in the next video.